Hey everybody, today I'm going to explain how to do like kind of very simple lightweight testing in both Python and JavaScript, and I'm going to get a little bit into the concept of mocking and try to motivate why mocking can sometimes be useful. And we are looking at a repo that I pushed up to GitHub, and you can see that there are, let's see, about 9 files in here. Setting aside the README, you can see that there's for every JavaScript file, I have like the exact equivalent in Python. And the what's happening in both programs is I basically make a function to produce a quote unquote plot of function values in those programming languages. So I think I'll just kind of jump right into the Python example. So I have this Python code, and it imports this thing called a simple plotter, and that simple plotter is basically responsible for plotting the value of a function. And the premise here is that this simple plotter would actually be like an actual like graphing library, and it is difficult to test like real user interactions or real user interfaces. But going back to um, calc.py, my browser's being a little slow. I apologize. We have a function called double, which returns twice a number, a function called triple, which returns twice the number, and you can use your imagination that, like a real world example of this would be using more interesting functions, but this is obviously a little bit contrived for instructional purposes. And then we have this function calculate that basically calculates the value of a function that you pass in as f. It just calculates it over the range of x values that you pass in. Or I guess a more precise way to say that would be over the domain of x values that you pass in. Although saying range actually makes more sense, I guess, from a Python perspective. And then we have this function called plot function with plotter. It gets passed in some x values. It gets passed in this f, which is just supposed to be a mathematical function, which will typically be double or triple. And then a plotter, which could be the plotter that we have within simple plotter, but it is passed in as a function. So you could call this function with any kind of arbitrary plotter, and we'll see why that's actually important when we get to testing. But the implementation of that function just calls this plotter helper that's got passed in with the actual concrete calculate method above here using the parameters x files and f, which again is just passed in. And then finally, like there's an actual need to like have some sort of concrete function that actually chooses a plotter with which to plot, and that is this plot function here. So it assigns to the local variable plotter simple plotter.plot, and then it calls plot function with plotter using the parameters xvals, which is passed into it, f, which is passed into it, and then plotter is just really simple plotter.plot. And before I talk about the test code, I hope you can sort of observe that some of these functions are going to be easier to test than the others. Like if you want to like test that the double function works, like you just want to make sure that like 4 times 2 is 8 and 5 times 2 is 10. And if you want to test that the triple function works, again, you just want to make sure that 1 times 3 is 3, 2 times 3 is 6. And if you want to test that the calculate function works, then you just pass in some in your test, you just like make up an array of x values and you call it with either double or triple, and you make sure that these tuples come back the way that you expect. And then in order to test plot function with plotter, this is where I think I just need to kind of show you the test code, because this is where things get like slightly more subtle. So we're going to go to the testcalc.py code. And we'll come back to this in a second. But as I said, like when you're testing the double function, it's like you're literally just like calling the function and you're asserting using Python's native assert function that the value returned by the function is the value you expect. And when you get down to test calculate, again, you're making a slightly more complicated function call, but you're calling into the calculate function with some array of values, and you're actually passing in the function that you want that calculate function to exercise over this range of values. And it apparently works because it returns this list essentially of XY tuples. But then we get to testing the like kind of like the abstract plotter. That's this plot function with plotter function. And when we do that, like we don't want to pass in an actual thing that would like print a bunch of stars to the console or fire up a graph in a browser. Like that's like beyond the scope of what we want to test. All we want to do is verify that whatever plotter that we pass in gets the values that we kind of expect, and we want to make sure that that plotter is actually called. And this is like sort of a broad notion of a concept called mocking. We were like fairly smart here in terms of how we created this function. Like we made a very testable function because the plot function with plotter function actually gets passed in a function, and as long as that function fulfills the contract of accepting basically like a list of XY tuples, then plot function with plotter just calls it. So when you're writing your tests, oops, that's the wrong one. Sorry. So when you're writing your tests, you can just pass in your own implementation of that plotter function that instead of doing actual like display related plotting, just asserts that the values passed into it make sense. And then in this particular test, I assign this variable called equal to true, and at the end of my test, I just make sure that this function was actually called. So I'm not testing like this plot function with plotter function in like the most end-to-end way, but I'm testing the fact that it fulfills the basic contract of the function. The basic contract of the function is that it takes these numbers, applies this function f over them, and then it calls some plotter to plot it. And like the details of how that plotter works are not like super important in terms of verifying that plot function with plotter does the right thing. Okay. And then we get to the final function, and this is where things get a little bit interesting. So in this final function, we're going to test that the actual plot, that the actual call to, where is it down here, calc.plot works as we expect. By the way, I have a little like random space before the comma, which is not intentional. But when you call calc.plot, notice that you pass in the list of x values and you pass in the function that you want to calculate over those x values, but you don't actually pass in the actual a plotter function because let me open this in another window. That might make it, whoops, that might make it a little more clear. Let's see. Yeah, in the actual calc.py function, excuse me, in the actual calc.py module, you have this plot function that very concretely calls simple plotter.plot. And you might think this is like a two-line function, so why do you even bother testing it? But I do think it's important to test it. Like, I mean, there are arguments that this function should really just like be in another file, like calc.py should be all like pure functions, and then this is like a glue function. This way of like wiring up like an actual concrete implementation of a plotter to another sort of helper function that wraps it. That's like a glue function. And generally, like glue functions, if you construct the software correctly, are going to be really small. So you can put this in another file, and then you could just say, well, I'm not even going to bother unit testing it because it's so simple. But I mean, it is relatively easy to test with this pattern here. So this mock plotter here is constructed in a very similar way to the other one. In this case, we're only passing in x values of 1 and 2, and we're actually only using the double function, so we generate these results, whereas up here, our f function was actually a composition of doubling and tripling, so that, you know, and we passed in more x values, so like the values here are a little more interesting. And there's a good reason for that. When we're testing the abstract plotter, like we want like a little more detail about what's actually happening. Like what we're doing here is we're actually testing that, like, I mean, this might even be a little bit of overkill for testing plot function with plotter, but we want to test that it's actually executing some interesting function over some interesting range of values. Whereas down here, like we do a basic sanity check on what values get passed into us, but what we're really mostly concerned with is just like make sure that the function gets called. Make sure that simple plotter.plot gets called, and if you come back here again, you have plotter equals simple plotter.plot, and you're calling plot function with plotter using that function. And the details of how you test this, that's where things get like a little tricky, especially if you're like a relatively new Python programmer. But we have this helper called with mocked value, and we pass in calc.simple plotter, which is the name of a module, just to be clear. And then plot is the name of the function that we want to override. And then mock plotter is the name of the function that we're actually going to override that function with in our test. And then finally, after mocking calc.simpleplotter.plot with mock plotter, we're going to call calc.plot, and that will sort of indirectly invoke this mock plotter to make sure that the right things are passed in. But because we're not actually calling this concrete implementation of simple plotter.plot, there's going to be no like output to the screen. So we're just going to like be able to validate that we are passing the right things. So again, this isn't like the quote unquote drawback of a mock test is that you're not like testing the full operation of a function, but the great advantage of using mocking is that you're just testing the actual contract of the function. Like what is it supposed to do? Not like all the way down, but like just on a high level. The purpose of calc.plot is to calculate the values of a function and then pass it into some plotter. And we don't really care what the plotter does. What we care about is that we are passing in the correct set of values to the plotter. That makes sense. And then coming back up here, we have this helper here. And by the way, this is like not like the most Pythonic way to do mocking. In Python, you have this really awesome concept called a context manager that leads to a more idiomatic way to do mocking. This function here is kind of constructed so that I could make the JavaScript code look like the Python code. But in Python, you would do this differently. But this isn't like a terrible way to do it in Python. So basically, with mocked value, it gets passed in an object and an attribute and a value. And it saves off the old value, and then it sets the attribute of the object to be this new value, which is essentially usually the function, usually the thing that you are mocking. And then it calls the function that you are testing, and then it sets the attribute of the object back to the old value. So I think I'm going to stop there. I mentioned earlier that like basically I have JavaScript equivalents for all the Python functions, but I'm going to save that for a follow-up video because I think maybe this is sort of self-contained here, and I can always like connect up the links. So anyway, thank you for listening. Bye.